Hi everybody, I'm Kathy Resnichek and I'm with the Ventura County Office of Education.
Hi, I'm Richard Pressler. I'm Chief Technology Officer for All Connected. We're a consultancy for several school districts.
And we're here today to introduce the Wired Networking course through the TAPT program. So Richard, tell us a little bit about what you do with K-12 school networks.
Sure, absolutely. So, like I mentioned, we consult for them. So generally that means that we need to design and architect the network infrastructure that goes into K-12 schools. And along the way, we also end up being involved with the implementation of the network and to some degree the operation. So we offer some co-managed services where we work alongside the IT staff in order to manage the computer network infrastructure.
That sounds great. Is there a typical K-12 network these days, or are networks different or around the state or around the country? Tell us a little bit about K-12 networking right now.
Well, networking, as we're defining it in this course especially, is based on standards. So there are a lot of commonalities between the way that the network is built in a school district and the way that a network is built in an enterprise or a commercial entity. But there are some differences. For example, recently, in recent years, there's been an initiative to give each student a device. So these one-to-one initiatives mean that we have a lot more devices inside of the network.
But aren't those just on the wireless?
Exactly. So the wireless pressure has gone up. There's a lot more access points, but those access points have to plug into something.
Oh, okay.
And so that's where we get into the wired infrastructure. So when we go back a few years, we used to have computer labs, right? And we would have all these computers in one room, say 30, 35 computers, connected up to the network. Well, now we have computers essentially all over the campus, connected wirelessly, and so we've had to distribute things. So now there's a lot more drops, there's a lot more switch ports used for these access points. Smart boards, for example, they're also often attached. Apple TV devices or any kind of a smart TV device, they're often also attached. So the wired network needs has basically increased dramatically within K-12, and that's driven up the number of switch ports and other elements.
Great. So this course particularly focuses on the wired part of the network, right? And there's another TAPT course on wireless networking, right? Okay, so we're wired and wireless, but they work together.
Absolutely. It's still the network, but when you deal with wireless, you deal a lot more with radio frequencies and things like that, and that course dives into all of that.
Okay.
But we know that you have to attach it all to something, and so we address that on the wired side.
Okay, great. So in this particular course, then what are those pieces that we are going to need to address? Can you explain a little bit about what the modules are?
Sure. So the course is broken up into 5 distinct modules. Each module has a collection of assignments, and I envision it kind of like a pyramid, where you start at the bottom and you basically have to build that foundation. And so that's module 1, Network Fundamentals.
Okay.
And Network Fundamentals is all about the things you can see, so the cabling, the switches, the routers, all of these physical pieces of equipment that make up a modern computer network. And then at the end of Module 1, we're going to talk about something called the OSI Framework. And that framework gives you an abstraction to think of all of the layers of the network and to visualize them and also represent them on paper, obviously, so that you can understand that the network is really built on several different components and layers and protocols, and that gives a foundation for the next modules.
So OSI, I'm assuming we're going to have a lot of acronyms in this course.
Yeah.
Because I know
education
loves them, and I know that technology loves them too.
Yeah.
So, what does that stand for? And just to give us a little taste of what we're going to dive into in that.
Sure. So it stands for Open Systems Interconnection, and like I said, it's a framework. So you would say Open Systems Interconnection Framework or OSI Framework, and the open part is important in that. Because it basically indicates that this is a collection of protocols and a way of visualizing a network that's not manufacturer specific.
Oh, that's probably really important.
Yeah, that's very important for this course. Because if you build a network that's only specific to one manufacturer or proprietary, then it would be difficult to interconnect it with other manufacturers, other devices. And many years ago, that's how networks were built. If you chose a manufacturer, that manufacturer would dictate how the network was constructed. But over time, the industry has recognized the need to open it up, and that's why today there's a lot of open source software, there's these open standards. All of those have happened within the computer network industry as well, and now we're in a place where we can talk about a framework in an open way. So basically we're saying that it's non-proprietary and when we're discussing it. Does that make sense?
That does,
Perfect.
and it makes me think of open educational resources.
There you
as
go,
well.
exactly, yeah.
So that was Module 1, Fundamentals. How about the other modules that are in the course?
So Module 2, we dive deeper into what's called Layer 2 and Layer 3 of the OSI model. So we're really going to focus on the LAN, the local area network, and the WAN, the wide area network.
Local, wide,
Yes,
right?
yep,
Okay.
exactly. And we're going to focus on the protocols that make those networks up. So we're going to dive deep into Ethernet a little bit. We're going to look at routing protocols, all the things that make Layer 2 and Layer 3 of the OSI model function, what makes that, what basically constitutes what you think of when you think of a network today.
Okay.
And we'll focus on that in Module 2. Module 3, we're going to get into network resiliency. So what happens if a piece of equipment fails? Generally, you don't want
But
the
that's
entire...
really important.
It is, it happens all the time.
Yeah.
And you wouldn't want the entire network to fail,
No.
right? So part of the discussion will be about resiliency, how to design a network for resiliency. And then we're also going to talk about quality of service, and that is how to prioritize applications. So there's several different protocols and standards for how you prioritize applications, but the need for it could best be illustrated this way. You think of testing time when all of
Right.
these students are
Okay.
online taking a test. Well,
Right.
during that time, the most important application on the network is probably the testing application, right? And you wouldn't want somebody else to take up bandwidth on the network, or at least not in a way that would affect the testing, just, downloading videos or whatever.
Pandora.
Streaming music, exactly. They're looking at a movie on Netflix.
Right.
All of those things take up bandwidth. And so for the network administrator, it's important to understand how to prioritize specific applications.
That makes a lot of sense. 'Cause you certainly want to make sure that the essential components are getting the bandwidth they need when they need it.
Yeah, exactly. If
Right.
your network uses VoIP, for example, the calls will be choppy. They
Right.
won't sound good if the network is not performing well.
Makes sense.
So that's important. And then Module 4, we're going to focus on security. Now, security is a very broad topic. In fact, there's a whole other
Yeah.
course on end-user security.
Okay.
And it focuses on behavior. So how does the end user behave? We're not going to talk about behavior. We're going to talk about what a network administrator can do to secure the components of their network. So we'll talk about firewalls.
Okay.
We're also going to talk about things that you can do on individual pieces of equipment to secure them. And also we're going to talk about authentication. How do users on the network, how are they authenticated?
Okay, so that's like the sign-in process?
Yeah, the sign-in process. Think of it like the sign-in to wireless or the sign-in to the network itself. There's protocols that determine how we authenticate people. There's also protocols that determine what they're allowed to do on the network. We call
Okay.
that authorization. And there's even standards for how we log what they did. How do we keep a log and a history to show if somebody's doing something malicious on the network, for example. And that's called accounting. And so we're going to dive into those.
that's probably pretty important, and it
Yes.
has some probably legal ramifications as well.
Potential, yeah. If you didn't take certain measures, then you could be viewed as liable in a way because you didn't take the measures to protect yourself that are at least common to the industry.
Right.
I will say it's an area that many school districts are lacking in, just because there's a lack of formal training. So I'm gonna try to not dive too deep, but I'm gonna try to go in deep enough that you can implement some additional security measures in your network and protect yourself a little bit better.
Yeah, that
And
sounds
then,
great.
And then Module 5, we're going to focus on troubleshooting. So this
Probably
is
really important.
Yeah, this is usually what a network administrator is hired for in the first
Yeah.
place, right?
Yeah.
Is
Good problem solver.
Exactly. There's a problem. How do you
Yeah,
solve it?
yeah.
So we're going to focus on troubleshooting, and we're going to focus on troubleshooting at a pretty low level. So we're going to use a tool called Wireshark
Oh.
that does packet analysis and digs into what the packets look like
Mhm.
and how to determine if there's a problem from a packet analysis perspective. And also a tool called Nessus, which does security analysis and gives us a nice view into whether or not elements of the network need to be upgraded or secured.
And are these tools expensive, or can
No,
most people access them?
Yeah, everything we're going to show and do is all open source
Oh, that's
tools
probably-
or free
that's
to
great, yeah.
download. It's important in this course, I feel, not to focus on a specific manufacturer or an expensive tool set because it may not be accessible to everyone. And therefore, we're going to focus on these tools that are readily available and also very common in the industry. So once you learn how to use this on one network, it doesn't, it'll apply to every network, anything
Okay.
that you
Great.
deal with, even your home network if you wanted to. You
Okay, great.
could use Wireshark to sniff packets on your home network if you're curious what your kids are doing.
Okay. Well, so I'm an educational technology specialist, and so some of the terminology and things you were talking about, I understand or at least have an idea of, but there's probably going to be a lot of stuff in here that I wouldn't understand. Is this course only for people who are already experts, or is this course designed for people of various levels for learning?
Well, the course was really mandated by the need to have some way of educating people who have been put into an IT role, but they don't necessarily have the background.
Oh.
So first and foremost, it would be for an audience of people who are now responsible for a computer network, but they didn't have a computer science degree, for example. Maybe they were an educator, maybe they were a teacher.
Like me?
Yeah, and now they're being asked to be the IT director or an administrator. So really for that person, starting at the beginning and going through to the end will help give them a breadth and a depth of knowledge necessary to operate their own network. But for the more advanced people, I would say there's bits and pieces in here that are going to be very beneficial to them. For example, we talked about quality of service and security, right?
Right.
So you could implement and operate a modern K-12 network without really addressing those two things.
Okay.
But if you focused on those modules, even as an experienced administrator, you should be able to glean something out of it that'll help improve your computer network.
Well, the course just sounds great. So looking forward to learning more as we move through each of the modules. So
Excellent.
Thanks so much.
You're welcome. Thank you, Kathy.
Bye.
Bye.
Hey everybody, we're back to the TAPT Wired Networking Program, and we're going to be talking about Module 1, Network Fundamentals.
Hi, I'm Richard Pressler.
And I'm Kathy Resnichek. So, networking fundamentals. It sounds like a kind of an easy subject, but I bet it's a little bit more complex than what it sounds like.
Yeah, there's quite a bit there. Basically, we've been doing computer networking since the 60s and 70s, so a lot of time has passed, and there's been a lot of advances over time. So there's quite a bit to discuss, even at the fundamental level of how modern computer networks are built. We're really going to focus on how a modern school district would look and how a modern classroom would look. We're not going to dive too much into the history because that would be a whole course. In fact, there are courses just devoted to computer technology history.
Well, and you said 60s and 70s, and I know I'm a tad bit older than you, so my first experience was playing Pong on a television set, and that was pretty awesome. So. So one of the subjects that we cover in this network is structured cabling.
Mm-hmm.
So structured cabling, what is it, and what does it look like in a typical K-12 school district?
It's a term used to describe the copper cabling and the fiber optic cabling that makes up a computer network. So essentially on the wired computer network, you have to have some medium to transport bits of data, and that medium is the structured cabling. So in a modern K-12 setting, for example, you might have a campus that's made up of several buildings. Now between those buildings, because of the distance between them, you would end up having to use, say, fiber optics because it can transport data at a longer distance than the electrical transmission through a copper cable. And so when we use copper cabling, it's cheaper, but it does have distance limitations. And so that's a way to think of it, is that oftentimes in a K-12 setting, especially here in California, where we have multiple buildings on one campus, it's very common for us to interconnect all of those buildings back to the MDF using fiber optic cabling. And then once you're inside the building, it's very common to go from the patch panel to the desktop using copper cabling. And usually that's because of cost. It also is because the copper cabling can deliver power for certain things. So for example, to power up a telephone or to power up an access point, you may not want to have to run power to that location just for that device. You can actually deliver that over the copper cabling from the switch. And that's one use.
So copper is less expensive than fiber optic?
Oh yes.
Because we always hear about people, scavenging for copper and stuff, but it's still cheaper than fiber optic.
As the the components may not be the metal itself. The copper metal has value. That's why you've heard of people
Oh,
stripping
okay.
it out of buildings. Fiber optic, once you strip it or damage it in a way, it becomes useless basically.
Okay.
You can't melt it down, it's just glass.
Okay.
But the manufacture of it is expensive.
Oh.
And actually making a fiber optic cable is rather expensive. So when you go to purchase it, you'll see the cost difference. And the other thing is when you take a normal computer and plug it in, it's ready for copper cabling. That's what a computer that has an Ethernet port. It's designed for what's called an RJ45 connector, but basically it's designed to plug in a copper cable. You have to buy a special card or adapter for your computer if you wanted to plug it into fiber optics.
Wow, that's really interesting. I never even thought about it. Didn't know that. So there you go.
There you
That's
go.
great. So when you're thinking, you kind of got into this a little bit when you're talking about distance and from building and what type of transmission, but are there any other special considerations about choosing the different kinds of cables in a K-12 setting besides just the distance? You mentioned one thing about power. I'm sure that must be really important.
Yeah, if you need to deliver power over the cable, you can't do that through light, obviously. A fiber optic cable carries just light. So if you need to deliver power alongside the data, then copper is important for that. When it comes to speed, though, fiber optic generally can go to higher speeds.
Okay.
So for example, the first 10 gig networks, and now we can do 10 gig on copper as well, but the first 10 gig networks were really using fiber optics to transport 10 gigabits per second of data. And to date, we haven't seen a 40 gigabit per second transmission on copper yet, although there are standards in the works. But on fiber, that's not uncommon to go to 40 gigabits or even 100 gigabits per second using fiber optic cable. So speed is one of the differences. Like we mentioned earlier, distance. So on a copper cable, the standard is 100 meters. As you can imagine, that doesn't get you very far.
No.
Even in some buildings, we have to have multiple patch panel locations because of that limitation. It's easy to go over 100 meters in a building.
Yeah.
And then you can just imagine going between buildings. Well, now you have to obviously go much greater distances. There's also electromagnetic characteristics.
Oh,
So
okay.
a copper cable could be a victim of induction. You could actually have electrons that affect the data flow of the copper on the copper cable. That would typically be in a manufacturing setting, not so much in a school district, unless perhaps you ran a copper cable like next to an elevator or some big piece of equipment. But that is a factor in choosing your cable, and so sometimes we implement fiber optic cabling just because of electromagnetic interference that could affect data transport on the copper cable.
So picking the cable there's a lot of choices and a lot of things you have to consider.
There is. Thankfully, as you dive into the course, you're going to see that it's kind of narrowed over time.
Okay.
It used to be a vast array of choices.
Okay.
It was really overwhelming.
Yeah, and now it's getting
But now
better.
it's pretty, basically you'll end up with Cat6 copper cabling, and you'll end up with either OM4 multi-mode cabling or single mode on the fiber optic side. But you're essentially going to be narrowed down to those three choices, really.
Well, okay, good.
I'm sure that makes it so much easier.
Yeah,
I
well,
know.
3 is better than 30, so.
Yes.
Okay, great. So another component that we look at in this module 1, is equipment and installing equipment. So are there things that you need to consider? And I'm sure that you've seen some interesting equipment installation examples. And do people tend to make the same mistakes if they make mistakes, or is it the whole gamut?
I've seen some strange ones. The most common one is using an equipment room for network equipment that's also used for other things, and that can cause a problem. So I've seen some rooms where it was also the gym storage room, so all the gym equipment is in there, and you just can't get physically to the network equipment because there's so much stuff in your way. A common one is to use an electrical room, and some of the problems we run into there is they tend to be very dusty and dirty. as you can imagine. Sometimes they have exterior facing doors, and so as the janitor, blows off the sidewalk,
Right.
he's blowing all the dirt into the equipment room.
Yeah.
It goes under the door, it goes through the grill, whatever. Well, the problem is that the network equipment is often very expensive, and it pulls that dust in, and it'll coat the equipment.
Oh, because it has airflow.
Yeah, it has airflow,
Oh,
and
okay.
it'll create
Yeah.
a thermal problem. It'll eventually start to overheat, and it could even fail. And so, one of the saddest things for me is to see a piece of equipment that cost the school district $5,000 or $6,000 even, and sitting in a room and just dirty, just collecting dirt and dust. Besides that, because of airflow, it's important that we maintain the equipment at the manufacturer's specs for temperature. So usually that requires some kind of an air conditioning unit. Here in California, there's some school districts that can get away without it,
Yeah.
depending on how close they are to the coast. But still, you might have salt in that case. You might have to deal with conditioning the air just to get the salt out of it, or other things. Because at the end of the day, it is essentially kind
Yeah.
of like a computer sitting
Yeah.
there in that room. I mean, they can tolerate a lot, but they don't live forever, these switches and routers and
Yeah.
pieces of equipment. I had one district even that every day the network switch would fail, and then about an hour later it'd come back on. Well, we found out that there was a potted plant sitting above the rack, and every day somebody would water the plant, and the water would seep down into the switch, short it out, and then amazingly, after it dried out, it would turn itself back on and function again. That's not
ghost in the machine.
It
right?
was, yeah, it was the strangest problem. And that's obviously not desirable, you don't want
No.
that.
Yeah.
I think most people would see that there's a problem
Yeah.
with doing it that way, but it does
Yeah.
happen. And so in some situations, it can come down to, is the equipment locked up? Is it
Right.
in a rack? Is it in a room? Is it somewhere that people just can't get to it? So they can't put a potted plant on top of it. Yeah, so there are those types of considerations. Here in California, we have to consider earthquakes. So when we're putting equipment into a rack,
yeah.
it's important that the rack is secured properly. Because you can imagine during an earthquake, you don't want this heavy piece of equipment flying
Well,
around the room.
You don't want it flying, and you don't want, thousands of dollars
Yeah.
worth of equipment.
Damaged, yeah, exactly. So you want it secured correctly, you want the racks to be bolted to the ground, the equipment should be mounted in the correct location in the rack. And so some of those things are gonna come out during the instructional videos. You'll see some of the guidelines related to how things are
that'd be great,
secured and
yeah.
how, where they fit in the rack. Also in California, it's important to put heavier things towards the bottom of the rack, and then lighter things towards the
that
top,
makes more sense.
which also makes sense,
Yeah,
right?
yeah.
So that it doesn't end up being too heavy on top.
On the top.
So those are just some of the considerations.
Sounds like there's a lot to learn.
There's
Great.
There's a bit to think about.
So we talked about equipment installation, but then what are all those pieces that you're installing? So one of the things I think that this module touches on is the different types of
Yes.
equipment. And so is the network type of equipment in a K-12 school different than other networking, or is it pretty much the same in any network, or is there anything that's unique to a K-12 situation?
Not typically too different. The switches that are made by the manufacturers, they're not made for education.
Okay.
They're made for a variety of different audiences. But there are some situations that come up that are somewhat unique to K-12. But the piece of equipment we're talking about, generally it's switches. We'll talk a little bit about hubs, mainly in a negative sense. That's an older way of connecting computers to a network. But you've got your switches, you have your routers, you have your firewalls. Those are the primary components that basically make up the computer network. As far as the types of equipment that are used in K-12, there are situations, for example, in a hot room that you know the temperature is going to be really, really warm, like most of the time. You can buy equipment that's graded as industrial specification, so it'll have a higher temperature rating than other equipment. Now, I used to not really have any K-12 school districts interested in this, but recently, as more school districts have done energy initiatives, where they've taken out HVAC systems, or they've done other things where they're allowing the temperature to rise, they have started purchasing some of this industrial grade equipment.
That's interesting.
That's a fairly recent trend.
Yeah, great. And then I think finally in this module, you talked about, and we talked about this in the intro video too, was the OSI model.
Mhm.
And it was the open Systems interconnection.
Good.
Almost had it. I remembered open because I remember you saying that was the important part.
Yeah.
Was that it's open. So, what are you going to delve into when you talk about the OSI model?
Well, we're going to dive into the layers of the OSI model. So just to give you kind of a precursor to all that, we were talking about cabling, right?
Right.
And switches and all this. Well, in order for bits to flow, in order for bits to cross a cable, whether they're crossing it as light in a fiber optic cable or copper, there has to be some agreement as to what those bits are going to look like. And when the receiving party receives them, he has to be able to interpret what the sending party was sending him, right? So you have to turn bits into, say, hexadecimal, into ASCII, into all these other character sets or whatever you're doing to understand what it is you're talking about. And so the OSI model is a way of representing cabling, for example, as layer 1, the physical medium. And within that physical medium, you could have copper cable, you could have fiber cable, you could even have wireless communications. But the point of it is that there has to be some way for the bit to get from point A to point B. And so the OSI model is a good way to talk about that without getting into the details of exactly how you're doing it. So
Okay.
within layer 1, you would have a variety of copper cable standards
Okay.
and fiber cable standards, a variety of wireless standards. They all would fit within layer 1. And then when you get to layer 2, you start talking about data links. So now it's the agreement of the language. So both parties that are talking on a computer network, they need to agree on the language. So for example, you and I agree that we're speaking English.
Yeah.
I speak it, you understand it.
Right.
Now I could
Most
speak
of the
it,
time.
I could speak it, if you don't respond, I don't know if you understand it.
True.
That can happen on a computer network too.
Okay.
One party could be talking and nobody's really listening. It's possible. But if they agree and they're having two-way communication, they have to have a standard. And layer 2 is a very low-level part of the standards of how computers talk. And then layer 3 gets into a higher level, a more logical level of standards and protocols that are necessary for two computers to talk to each other. And then layer 4 talks about the session. As an example, right now we're having a session where if I
Okay.
say, can you hear me?
Yes.
You
I
say
can hear.
yes, and it's a response, and I know that that's basically an acknowledgement.
Okay.
Well, layer 4 addresses how computers acknowledge each other with their sessions and basically communicate from one party to the other, how that party responds to say that they received the communication. If they didn't receive it, then the first party may have to resend it. So that concept really gets into layer 4 of the OSI model. And then layers 5 through 7, we're not going to spend a lot of time on because that's really the realm of programmers. That's how applications talk
Okay.
to each other. So when you open up your web browser and it needs to talk to a web server, you are opening up an application.
Okay.
And of course it has to go down through all the other layers. So it has to go through layer 7, 6, 5, 4, 3, 2, 1 in order to ultimately communicate. But when you talk about a network, we're really focused on layers 1 through 4 of the model, and then layers 5 through 7 get much more into the application. So we'll touch on it, but we're not going to get too deep into
Okay.
those layers.
Well, I know human communication is complicated, and
It
it
is.
sounds like network communication can be a little bit complicated too, because you've
It's
got
less-
to make
it's
sure
less nuanced.
less nuance, but you got to make sure that you're sending and receiving what you think you're sending and receiving,
Yes.
right?
And you have to have an agreement on language. You have to have, that's why we have terms like IP, Internet Protocol.
Okay.
Well, that's a language. That's
Oh,
basically
great.
a protocol for two things to communicate. They're going to agree on what that looks like. And we'll talk about that quite a bit in Module 2. But in Module 1, we're sort of setting up the framework so that we can at least have this discussion going forward. And you understand as you learn more things where it fits. So when we talk about cabling, you now know that fits into layer 1. When we talk about the data link layer, and later on we'll talk about MAC addresses, well, you'll know that fits into layer 2. You talk about an IP address, well, that fits into layer 3. And so it helps organize the conversation, as well as being a good framework that most of the industry agrees on.
Sounds great. So